Tonight's video is on section 4.1, Antiderivatives and Indefinite Integration. This will be the first section out of our new chapter, Chapter 4. Your homework out of this is 1 through 41 odd. To begin with, antiderivative, another word for that is indefinite integration, is the inverse of differentiation. In other words, taking the derivative. And differentiation, when we've been taking the derivative, this is the inverse of antiderivatives. So we've been taking derivatives. Now we're going to go back to a possible original equation, and how we're going to go back to the possible original equation is by taking an antiderivative. So let's just take a look at some examples and see what this looks like. Example. Let's say I'm given, and I'm going to write it as the first derivative, y prime equals 3. Now let's just kind of guess and check. If I wanted to go back to the original function, because this is the first derivative, go back to the original y function, what might that be? That might look like this. Because if I go ahead and I take the derivative of this, we write down the 3, we take the power of the variable 1, bring it down, and then we decrease that by 1, which would be 0. So that would just be 3. But couldn't it also be y equals 3x plus 4? Because when I take the derivative of this, this goes to 0. When I take the derivative of this, won't it go to 3? Or it could be, 3x minus 1/5. It could be y equals 3x minus square root of 2. It has no variable x in it, it's just a real number. So again, when I take the derivative of this, that's just 3, and that's all that it is, which was my original function. So what we did to go back was we guessed and checked. This process of going back is going to be called the antiderivative, or taking the indefinite integral. And so when we did this, we found out that I could have all kind of a constant here. So the way we're going to take this, we're going to write it plus c, and that c is going to be called the constant of integration. That accounts for, it could be all kinds of different real numbers. We don't know exactly what real number by going backwards. I have no idea. But I know that there could be 1, or it could be 0. There could be none. So now let's do some problems and look at the notation for antiderivatives. So let's start with, if my derivative, my first derivative, is written like this, and I'm supposed to go backwards or take its inverse, which is called an antiderivative. So what we do, dy, and we're going to multiply both sides by dx, and then I'm going to go ahead, and here is the notation. We're going to use this sign here. This is called the integral sign. That's what this thing here is called. And I'm going to do that on both sides. This happens to be y, and I'll show you that in a minute. And this one here happens to be x squared over 2 plus c. Now, how did I come up with that? Again, if I just do a guess and a check, when the original function was y equals something, and when I take the derivative of it, I take the derivative of y with respect to x. Well, now I'm going to undo it. I'm taking the antiderivative. So to undo this with this integral sign, it's going to end up being y. So here is with respect to x. I have my x variable. So this is after I took the first derivative, I got the x. So how do I go backwards? How do I go backwards? So what you do is this has a power of 1. You increase that power by 1, which is up to 2, and whatever that power is, you divide by it. And that cleans up to be 1/2 x squared plus c, my constant of integration. Let's check. Let's check, and if I go ahead and I take the derivative, if I take the derivative of this, am I going to go ahead and get back this original function here? So let's take the derivative of y. That means I write down my 1/2, I bring down the 2, write my variable, I decrease that by 1, and this is just some real number, so that goes to 0. So 2 times 1/2 is just 1, and that's just x to the first power. And that's what I had. Because another way of writing y prime, or the first derivative of y, is dy dx equals x. So this is the antiderivative of dy dx equals x. This is the antiderivative. So I'm trying to go back and find the original function. Okay, so let's go ahead and let's do another problem. Now I've already set this equal to y. And this here, the 3x, is my first derivative. I want to undo it with the antiderivative, with this integral sign. I want to go backwards. And this is saying this with respect to x, which they happen to match. I can rewrite this by taking the 3 on the outside, because that just maintains. Now I'm going to go ahead and take the antiderivative. I'm going to write down my 3, write down my x. It has a power of 1. I'm going to increase it by 1, which is to 2. Whatever I write here, I divide by that, plus my constant of integration. Let's clean that up. That's 3/2 x squared plus c. In your homework, they're going to be asking you to check to see if this is a good answer. How are you going to check this? You're going to take the first derivative and you should get back to this original function. So let's take that first derivative. Write down my 3/2, bring down my 2, write the variable x, decrease it by 1, and the first derivative of a constant number like a 2 or 3 or 1/2 is just 0. So let's go ahead and let's clean this up. Let's see, these two cancel, so that's 3x, which is my original function. So this is the antiderivative of this original function. I might as well make the notation here that on page 250 there's a gray box. There are some basic integration rules. I'm not going to write those out on this video. It would take me too long. But you must have these memorized. Please make sure you take a look at those before you come into class tomorrow. Let's just continue and do some more problems. So let's take the antiderivative of 1 over x squared dx. First thing I'm going to do is rewrite this, just like we did in taking the first derivative. Now I'm going to go ahead and take this antiderivative. I'm going to write down the x. I'm going to increase the exponent by 1. And whatever I write for that exponent is what I write underneath, plus c for the constant of integration. So when I clean that up, that'll be negative 1 over x plus c. And I'm not going to check all of these. I will periodically stop and check some of these. I just want to get out a few examples. So here's this function, x times x squared plus 3, and we're going to integrate it. We're going to take the antiderivative. Again, this is the first derivative. I want to go backwards. Again, these are inverses of each other. So the first thing I'm going to do is I'm going to rewrite this. I'm going to multiply that through. Now I'm going to go ahead and take the antiderivative of this. So I'm going to write down that x, increase that by 1, divide by that. Just leave the 3 there, take my x, increase that by 1, divide by that, plus my constant of integration. Now I'm just simplifying this. Again, we can go ahead and we can check this one. Let's just check this. I'm going to take the first derivative, 1/4, bring down the 4, decrease, bring down the 3/2, bring down to 2, decrease, and that just goes to 0. So that's x to the 3rd plus 3x, which is originally what we had. Let's try a few more problems. We're going to integrate the square root of x plus 1 over 2 square root of x dx. First thing I'm going to do is rewrite that, x to the 1/2 power plus 1/2 x to the negative 1/2 dx. Now when you look on page 250 for the basic integration rules, you'll notice I could also split this up with addition. X to the 1/2 dx plus, and then bring the 1/2 on the outside, x to the negative 1/2 dx. So I have this piece, but it has to be times dx, plus I can take out the 1/2, let it just sit there, and I'm taking the integration or the antiderivative of this second component. So now I'm going to go ahead and I'm going to take the antiderivative, write down the x, increase this by 1, divide by that exponent, plus, write down the 1/2, write down the variable x, increase negative 1/2 by 1, that would be 1/2, divided by 1/2, plus all I need is one constant of integration. Let's go ahead and let's clean that up a little bit. Multiplied by the reciprocal. That's just 1. Now this is really x to the first power times x to the 1/2. I could take out an x and put the other one underneath the square root. This is underneath the square root, so maybe it's written like this. It could be written either way, who knows? Either way is correct. Let's go ahead and let's see if I have anything else. Let's do one of the trig problems. So this is with respect to t. You can see that t is the variable. I'm going to go ahead and separate this one. Oops, I forgot the t there. So again, I'm going to write down the t. As I take the antiderivative, I'm going to increase this by 1 and divide by that. Write down my minus sign. And when you look on page 250, In fact, let me just grab that real quick. We're trying to find the antiderivative of sine. So, as you can see, the antiderivative of sine is going to be negative cosine. So let me go ahead and let's do that. It's negative cosine of t plus my constant of integration. I'm going to clean that up. That's 1/3 t cubed plus cosine of t plus c, my constant of integration. Thank you.